All right, guys. So quantum theory is pretty much how we describe an electron. We can describe it both as a particle and a wave. So we can quantize the energy, right? We can measure the mass of an electron. We can measure quantized energy of an electron. So a specific energy. But we also see it traveling as a wave because it creates interference patterns. So you'll hear a lot of arguments in the scientific community that, electrons are particles or electrons are waves, but really we have evidence of both. So it's not kind of like, is it one or the other? It's really that the electrons show evidence of a particle, but also evidence of a wave. So maybe it's something we haven't quite defined yet. But really, we see it as both a particle and a wave. The Heisenberg uncertainty principle basically says that you can never know the location of an electron and you can never know where it's going. And that's because, like, basically, when you take the measurement of the electron, you can, like, by the time you've taken the measurement, it's already moved. So it's like just by measuring it, it's already in a new spot. Therefore, you can't know both. You can't know its location and its like velocity, its speed or direction of travel. Um, Neil deGrasse Tyson does a good job of explaining this. So I'm going to play a little video clip here. Okay, so here it is.
So here it is. I'm looking at you.
Okay.
All right.
Yes.
And I see you. I want to know where you are. So I turn on the lights and I say, there you are. All right. Now, let's make you tinier. Let's make you mini me. Okay, like in the movie.
Right.
So now there's a tiny version of you, a mini me version of Joe Rogan. Now you're little. I turn on the lights, you're still there. Okay?
Okay.
Because if the lights are not on, I can't see you. I don't know where you are.
Right.
It's that simple.
Okay.
Okay? When you start becoming the size of molecules, right on down to the size of an atom, and I ask the question, where is Joe Rogan the atom? And I turn on the light to see you there, because I think you're there. The light, the photon comes in, hits your atom, and pops you into another location. The very act of trying to measure your position prevents me from measuring your position. And it doesn't have jack shit to do with your consciousness or your mind or your eyes or anything. It has to do with the fact that to know you're there, some information has to come from you to me, like shining a light on you. And the smaller you are, the more susceptible you are to the energy of the light changing your position in space.
So my question is,
You know
how
what it's
do
like?
they know?
You know what it's like? You ever, I don't know if this still happen, a quarter spills out of your pants pocket in the back seat of a car, and it's there in the wedge between the bottom and the back seat. And so you try to reach in to get it, and the act of reaching for the coin makes the coin move farther away from you. The act of reaching for it.
Right,
Because you're separated and it just slides down even further. That's not your mind making that happen. It's the act of the measurement that is affecting what it is you're trying to measure. And this was discovered in quantum physics, and to the point where it's the Heisenberg uncertainty principle. It's one of the basic foundations of all of quantum physics.
Okay, so Joe Rogan can sometimes talk a little over not Joe Rogan, Neil deGrasse Tyson can sometimes talk over people's heads, but I thought he did a good job there of describing the Heisenberg uncertainty principle, the idea that you cannot know where an electron is and where it's going. Basically, the closer you get to knowing where it is, the further you are away from knowing where it's going, and vice versa. So, we have gone over these quantum numbers a little bit in the electron configuration notes, but I did want to give you, a slide sort of with a table that just sort of identifies all of them nice and easy. So N is the principal quantum number, which is the energy level. We kind of know that from the last section too, when you guys were using Bohr's calculations to calculate N, right? We were calculating energy levels. The angular, which basically describes like the orbital. So Electron, the energy levels are numbers, but the orbitals we say is s, p, d, and f. So again, you guys saw that in the electron configuration notes. So there's only 4 of those. There's only s, p, d, and f. Um, Energy levels really, like as of right now, only go up to 7. Could it eventually go up to 8? Well, if we created like an 8s um, an 8s energy level, maybe. But that's about it. Like that's really as far as it goes. However, we do talk about energy levels being infinite because electrons jump from all sorts of energy levels. But measured for ground state electrons, it's really just 1 through 7 now. If we invented new elements into 8s, possibly one day there could be like a ground state 8 energy level. But right now there's 7. Um, the magnetic is just the orientation. So we know that S has one shape because it looks like a sphere. It only carries 2 electrons, right? So there's only one orientation. But we know P has 6 electrons, therefore it has 3 orientations. And the P orbital kind of looks like a blade from the fan, where it's like an infinity sign. That's a good explanation. And then the D orbital kind of looks like a 4-leaf clover, but keep in mind that these are all spinning in a 3D space, not a 2D space. So for me to give you ideas of what it might look like is just difficult. And then F, if you look in the book, there's all these weird orientations for F. Because you're operating with 7 different orbitals in this 3D space, it gets a little confusing. But there are pictures of that in the book, which you guys will see when you go through the outline. And then finally, the last one, the spin, which is just saying plus or minus a half. That means the electrons have to go opposite ways. And that was the Pauli exclusion principle. If you remember, that's why we do orbital notations, is to show the electrons going opposite ways. But that's pretty much it. That was describing an electron. And we call it quantum theory, and it's these big words. And honestly, if you go into chemistry in college, this does get significantly more developed. But right now, we're just kind of learning the basics of it. And that's really it. It's being able to describe an electron using the 4 quantum numbers. It is being able to measure an electron while understanding that you can't find it and know where it's going at the same time. And then finally, knowing how it travels, like as a wave or as a particle, really properties of both. Please let me know if you guys have any questions.